Okay, thank you everyone for being here. A little bit different today. Inside Tom's head, but with a little bit of chemistry. What I'd like to do today is take you through a few things. I'd like to take you through how we create hair color, particularly how we create different shades of hair color, and the way we really create brown, not what you've been taught through the years in school and everywhere else. I also want to take you through creating some beige shades and some high lift shades and a little bit of base breaking. So a little bit of everything today. And as always, everything is always open to discussion. Please let me know if there's something you don't understand or you want me to address something further. You can always reach me at tom@chromastics.com. Um, and I'm ready to go. So let's start with a chemical we're most familiar with, and this is called PPD or phenylenediamine. Now, phenylenediamine is the chemical that we test for allergic reactions. You can see by looking at this diagram here, it's just simply a white crystalline substance. It has no color to it. But we use this to create a lot of different shades of hair color. It's the basis of almost everything. The second chemical that I want to show you is this, which is resorcinol. Now, resorcinol is another plain white chemical. And what I want to do is I want to combine the two of them because this is something that no one's probably ever shown you before, but I think it's fascinating and it's the way we really create brown hair color in the lab or that you find in your tube. When we combine PPD and resorcinol, we combine them and we create first an intermediate molecule, and then it becomes this guy down here, oxazine. And now I want you to pay attention to this because what I'm going to show you next is the oxidation of these molecules and how we create a real large molecule that gets stuck in your hair, literally. And when we do it, it creates this big molecule right here. So it's N2 plus resorcinol. And with the oxidation of them, which means I mix them with hydrogen peroxide, and they form these very large molecules. And lo and behold, the color brown appears. We do not put red, we do not put yellow, and we do not put blue into the tube to create the color brown. We put phenylenediamine and we put resorcinol. Now, there are a couple of other ways of creating brown shades, but this is the most effective, the easiest, and what just about everybody does. That's how we create brown hair color. The larger this dye molecule becomes, the longer it lasts in your hair. And then we can make slight alterations to it by adding more than one coupler. Remember, phenylenediamine is the dye. Resorcinol is the coupler. The coupler is what forms the dye molecule or the larger molecule that gets stuck in your hair. This is a single dye that we use. It's called p-aminophenol. And you can see by looking at it that it's just it looks like dirt. It's just looks like crumbled up dirt. And it has no shade to it whatsoever. But then we take this and we combine it with different couplers, and depending upon how we shape the new molecule, we get a different color. So the first thing I'm going to do is I'm going to hook it up with resorcinol. Now remember, resorcinol was the one I used in the last example to create the color brown. Well, now this time what I'm going to do is I'm going to connect the two of them p-aminophenol and resorcinol, and this is the shape of resorcinol here. We hook this and this together, and lo and behold, we create this sort of neutral blonde, level 8, level 9, whatever you want to describe it, color by mixing together p-aminophenol and resorcinol. Easy. But here is the beauty of hair color. I'm going to take the same dye, the p-aminophenol, and I'm going to combine it with a different coupler. In other words, a different molecular shape that causes, when you hook them together, it to become a different shape molecule. So in this case, what I'm going to do is I'm going to hook together, once again, p-aminophenol, but this time I'm going to hook it together with p-aminoocresol. Now, this is a different shape molecule. Look at the shape, look at it. It's very similar than the other one, except it has a couple of other things on it. Let me go back and show you the previous one, which was this one right here. Now, you see this? Here, I've got two of the OH attached. On this one, what I'm doing is I've substituted it a nitrogen where one of the OHs was attached. Here's the other OH, but then I have a carbon chain coming off of it. So now I'm going to turn around and hook the two together, and lo and behold, I end up with this color that is a strawberry blonde, basically. So I'm still using the same dye, but I hooked it together differently with a different shape coupler, and it becomes the color strawberry blonde. Let's look at it when I take the same dye and I hook it together with another coupler. In this kind, I've hooked it together with 1-phenyl-3-methyl-5-pyrazole. And what do I end up with? I end up with this very light blonde shade. Same dye, different coupler, new color. So what I'm getting at here is very simple. You can take one single dye and create up to 7 or 8 different shades of hair color with it. Now, one of the reasons this is important is because when you're working with blended hair color, you have no clue as to what's in the tube. When you work with a pure tone like I prefer, you know exactly what's in the tube. When I tell you that it's a pure tone color, it means there's only one dye in that tube. And you turn around and you create the shade that you want. Here's another example of using the same aminophenol, p-aminophenol, and this time I'm going to hook it up with 2,4, and look at this. I now have a red-violet shade of hair color. And what is it? It's probably what we would consider a level 4-5, somewhere in there. A light brown, the level of a light brown or a lightest brown. And then one last one, I can create all different shades of soft auburns by once again the same dye and mixing it this time with 1-naphthol. So let me run back through all of these and show you. By using one single dye, I can create one type of blonde, I can create a strawberry, I can create super pale, I can create red violet, I can create auburn shades, all using the same dye. Fascinating stuff. This is why I prefer pure tone colors. I want to know what's there. Now let me take you on to the second topic that is terribly misunderstood in our industry. And this has to do with alkalizes. Now, we use, generally, there's 3 different alkalizers that we use in our industry. Ammonia, which is a gas, so of course it has to be dissolved in water, and it becomes ammonium hydroxide. Ethanolamine, also known as MEA or monoethanolamine. On a tube, just this part of it is generally in the ingredients where it says ethanolamine. And then the third one, which is not very common, but is the one that I use, which is AMP, amylomethylpropanol. Let me show you the differences between them and why I prefer one or two of them over another one. So let's start here. Ammonia. Ammonia is a gas. And it's a nitrogen uh, atom, and it is bound with three different hydrogens. I don't know what's dinging in my ear here. Who knows? So go over here now. Let's see. Alkalizer. Here we go. When we dissolve it in water, it becomes ammonium hydroxide. So now you can see that H, see there's two H's and O, that's water, H2O. But what we've done is when you put the gas, the ammonia gas in the water, it becomes a hydroxy ion, thus ammonium hydroxide, and and and, ammonium hydroxide. Look at the size of the molecule here. Now, this is the gram weight. So it's 35.046 grams per mole. That's the size or the weight of this molecule. Now let me take you down and show you, well, before I do it, now ammonium hydroxide is the most commonly used alkalizer in permanent hair color. It is extremely effective at catalyzing the peroxide. So you get both lightning action, you get the pH you need, and you create that alkaline environment for developing certain dyes. Here, we move down to ethanolamine, monoethanolamine. Now look at the size of this molecule here. First of all, you see from the shape of it, it's much larger than the ammonium hydroxide. But look at the number. Means it's 61.084 grams per mole. That's the molar weight. Tells you the size of the molecule. Let me go back and show you the ammonium hydroxide again, 35.04. And now we're looking at 61. So it's not quite double the size. Here's what this means. First of all, because it's so much larger, it's more difficult for it to penetrate into your hair. Therefore, it is more difficult for it to catalyze the peroxide. And what happens is by not being able to catalyze the peroxide as easily, you end up with a color that lightens less than when you use it with ammonia. In other words, when you use ammonia in 20 volume developer, you get approximately 2 levels of lightening. When you use ethanolamine and peroxide, you don't get 2 levels of lightening. You get less. You get around 1.5, maybe even less than that, depending upon the texture of the hair. So it's not only is it less effective, one of the things that I've found over the years is that when trying to use ethanolamine, it your colors don't last as well, as long. They tend to fade from the hair a little bit and a little bit more rapidly. And it is my experience, and there is some technical information to back it up, that ethanolamine tends to be very tenacious and stay in your hair and a little bit more difficult to get out of your hair. And when there is residue in the hair, it realkalizes and causes additional damage and that dry feeling. How often have you had a client who comes into the salon who has hair that they've done themselves at home with, I love the term organic, natural hair color. They bought it at the drugstore, and their hair looked beautiful the first day they did it. And it the instructions say it's semi-permanent, and it isn't because it's using peroxide and an alkalizer, so they're permanent oxidative dyes. The hair after a week or so begins to feel more and more like a bird's nest of straw, and then it starts going off tone. So all of these things can be attributed to the fact that the color in the drugstore is not always as good as it could be. Now, I don't use ethanolamine in anything. I think it's a horrible chemical, so I choose not to use it. But instead, I use aminomethylpropanol. Now, look at how large this one is. 89. Let me go back to ethanolamine. 61. Now I've gone all the way up to 89, almost 90 grams per mole. This means it is very, very ineffective, does not catalyze the peroxide very well, and therefore you get zip when it comes to lightning action. Um, Barely any, if there's any at all, you can't see anything because it's just not very good at it. That's why I prefer using this as the alkalizer in my products and not the not MEA or ethanolamine. Good, simple. You have the three chemicals once again: ammonia, which becomes ammonium hydroxide, ethanolamine, known as MEA, and AMP. We do not use any ethanolamine in any of our hair color products. I don't care for it. We use in the deposit only white tube of chromastics, I have AMP, and in liquid shades, I have AMP. The ammonia only appears in the permanent hair color, XL Cream, and XL Super. Next, let's move on to creating some beige shades. I love beige shades. They're softer blondes. They're always created by starting with golden, and you can create them both in blondes or you can create them in lighter browns. And I want to show you four different beige shades. Now, there's two ways to create beige shades. You can create a very soft beige, or you can create a cool beige. I'm going to show you both, and I'm going to start with level 10. Let me start with level 10. Level 10 gold. Now, in each one of these swatches was done individually. All three of them were done with 60 grams of 10G. Your first one here is plain 10 gold on pure white hair, pure white virgin hair, mixed with 20 volume developer and processed for 35 minutes. The second swatch, it's 60 grams of 10G plus 6 grams of 6 blue violet. When you add blue violet to green, you do not get a yellow green color like everybody thinks. Excuse me, to gold. When you add blue violet to gold, you do not get blue, and gold do not make green in chemistry. Instead, what you end up with is this very, very soft, beautiful beige blonde. So blue violet plus gold gives you beige blonde, soft beige blonde. Here, I added in this third swatch is 60 grams of 10G plus 2 grams of green concentrate, and I made a cool beige. You can also see that it looks darker. The reason it looks darker, because I've increased the dye load, and whenever something becomes cooler, it always appears deeper. So 10G by itself, 10G turned into a beige using blue violet, and 10G turned into a cool beige using green concentrate. This was with 10G. Now let me show you with 8G. Now once again, I've done 8G, a little bit more gold to it, and this time I used the same 6BV, and notice that this one is not as deep appearing as the last one. Let me take you back. Look at how much cooler this one looks. Let me go back to here. And the reason is because I have more gold in this one. So therefore, using the same amount of BV doesn't allow it to become as soft of a beige, as beige as the original one. But look what happens when I add 4 grams of green to the 60 grams of 8G, and I get this very cool almost a medium beige blonde. I think it's a beautiful shade, a very wearable shade. Beige blondes are just about everyone can wear a beige blonde shade. Now let me go from 8, let me take you down to a 6G, and look at how much more color. Once again, blue, violet, and green. But look at how what I've done here is I've increased it up to 12 grams of blue violet because I have a much deeper shade. And I've increased the the green, up to 6 grams of green. And then the last one I want to show you is using a 4G, which is light golden brown. And you see, when you get into the brown shades, beige is not as easy to see. So once you go beyond light brown, it's very difficult to see any beige. So the blue violet still does create a soft beige tone, the green a cool beige tone. But once again, it's difficult to see because we've gone into the brown category. Simple. I like beige shades a lot. Now what I want to do is I want to show you a high lift. And in this case, the high lift is I'm going to mix high lift super with concentrates. I'm going to use 2 ounces or 60 grams of XL super plus 60 grams of 40 volume developer. Mix it with 7 grams of each of the 5 concentrates and show you the result on a dark brown swatch. So I took a dark brown swatch, natural dark brown with gray in it. It has about 10% white hair interspersed with it. And then I used neutral gold, green, red, and blue. And you can see that each one of them, when mixed, 60 grams of XL Super plus 7 grams of concentrate, every one of them gives me a different color result, and every one of them is beautiful. So here's the the neutral, the gold, green, red, and blue. Whenever you put blue concentrate into a formula, remember it really gets deep and dark and takes over everything. So it almost makes your colors look a whole level darker than you're anticipating. Next, I want to show you base breaking. In other words, break the base, but using liquid shades. I'm just going to show you a couple of examples here. And what I like about this particularly is that I've taken 60 grams, 2 ounces of liquid shades. In this case, I used liquid 10N, and I added 15 grams of XL cream to this first swatch. The second swatch is with 15 grams of XL Super. So I'm starting here with a natural swatch that is a light brown with about 30%, 50% interspersed white hair. So it's 50-50 gray. I used liquid 10N plus 15 grams of XL cream. And I mixed it with 20 volume developer and only left it on the hair for 10 minutes. So this is the result that I got from number 1 with XL cream. And you can see with the XL Super, I have a little bit lighter of a shade because it did a little bit more of a base break using the XL Super, and the white hair took more of the 10N tone. So I prefer to use the XL Super because I like a little bit extra base break. And let me show you one more example using liquid 6N, which is your dark neutral blonde. Once again, same swatch, naturals 50-50, light brown and, excuse me, I said light brown, I meant medium brown. Medium brown 50-50. And here you can see what happens when you add the XL cream. The 6N gives you a lot of tone on the white hair, but doesn't do a lot of base breaking here. But here you can see a definite combination with the Super where you get a a little bit more of a base break, plus you get a better blend of the color because they have you've developed more of the dye and it's covered the white a little bit better. Simple. That's it. Today's a really simple presentation. I hope you've enjoyed it. Remember, you can always ask questions at tom@chromastics.com. And I'm already working on the next presentation. It'll be 3 weeks away. And we're going to go into individual shades of color next. I believe the next one is going to be all about red, creating red hair color on browns, on blondes, and on white hair, and salt and pepper. So I look forward to it. Thank you for being here today, and have a great